Good evening, everyone, and thank you so much for participating in the UC ANR Fire Network's After the Fire Water Resource Contamination webinar. My name is Katie Lowe, and I am the Fire Network's coordinator, and I will be one of the many folks from UC Cooperative Extension helping facilitate the webinar this evening. So just as a reminder, this webinar is an introductory webinar for interested residents, resource professionals, and community members who want to just learn a little bit more about the wildfire impacts on water resources post-fire. And I just wanted to give a quick disclaimer that during this webinar, you may see images of communities and areas that have been burned by wildfires. These images may evoke powerful emotions or strong feelings. If you need to step away at any time, please feel free to do so. We are really fortunate to be joined by two great researchers working in the post-fire water resource contamination field. We have Dr. Jack Webster from CSU Chico, and we have Dr. Chris Olivares from UC Irvine. So with that, I will stop sharing and hand it over to them.
Hello, everyone, and welcome to this webinar. Professor Webster and I are going to synthesize some of our experiences on working in the impacts of fires to drinking water, to surface water, and highlighting some of the case studies. So all of these slides and presentations are based off our research experiences, fieldwork experiences, and we hope they are useful to everyone in the audience. As we know of throughout the U.S., forested watersheds are very important because they provide up to 53% of people in the United States drinking water supplies. We often call these source drinking waters. And on average, according to the U.S. Geological Survey, we have about 7 million acres burned. This is a 10-year average of over 70,000 fires over this 10-year average. When we have fires, and of course, like fires are put out, the impacts might not end there when the fighting activities end. There are impacts to the soil, there's impacts to the vegetation, and in wildland-urban interface fires, there's impacts also to infrastructure. When we think about the impacts of fire to surface soil, we have the increased combustion, production of charcoal. Here we see three images from left to right. The left one, it's a more moderate burn. And as you go progressively to the right, we can see that there's more ash in the surface layer. There's fewer pine needles, and suggesting that also the structure of the soil is changing. When we think about like these changes in the soil, it means that after fires, the soil, especially if the conditions of the fire are severe, they can lead to immediate runoff, immediate floods and particulates flowing. And with doing so, also same contaminants that could be in the soil. We have, during this burning process, charcoal and ash production. We have also chemical reactions that are happening directly in the soil, as well as what is burning. Could be the vegetation. It could be also the infrastructure that makes up our homes, our buildings. And we see the formation of known combustion products. So one class of these contaminants are polycyclic aromatic hydrocarbons. They are well-known. Some of these are well-known carcinogens like benzoalpha-pyrene. And we also can have similar compounds that are quite soluble in water that are called benzene polycyclic polycarboxylic acids, or BPCAs. They're indicators of combustion again. And overall, as I mentioned, with progressive severity, and we would have storms that after the fires can lead to increased runoff and erosion in these systems.
So one of the key things for understanding how wildfire influences surface water and water quality in the watershed in general is also recognizing that there's background water chemistry happening as well. So prior to a fire, that water quality is going to have a signature that could be influenced by things like land use, such as agriculture, geology, mining, all of these activities can influence what's in the water. So when we're trying to understand the effects of fire, we need to understand those first, so then we can see how these other things are influencing the water quality. Generally, at least in California, our surface water quality is fairly well known. Maybe we don't have quite as much data as we'd like all the time, but for the most part, people have been out measuring water quality, and we understand water quality for most watersheds. When you burn the watershed, and you start mobilizing all of these various constituents that Chris just mentioned, now we have a more complex system, and all of this sediment, the soluble materials, particulates, all of this is moving into the watershed, and the watershed can respond differently to rainfall. So the amount of water coming out of the watershed is going to change. And all of this is moderately understood. It's still an active area of science, but there's been about 40 years of ongoing science. And in general, people understand that we have increased nutrient export, increased metal export, increased carbon export, et cetera, et cetera. Where we really don't know what's happening in the watershed is in these urban fires that we've been having more recently over the past decade or so, where you add in the complexity of burned urban materials such as vehicles, structures, and all of the various products associated with those structures. So this remains widely unknown right now. Some of the specific things that increase, again, fairly widely known and reported in the literature. Suspended sediments often increase, 1,000-fold. That's what's shown in this picture here. So just particulates that are being washed out of the watershed. And this is mainly that ash and charcoal. There's also an increase in the dissolved carbon that's coming out of the watershed. So as you break down these kind of macro structures from the vegetation, as you burn it, you're creating smaller molecules, and many of these are soluble and can be washed out of the watershed. So there are some examples of those pHs and BPCAs that Chris mentioned earlier. The nutrients and metals, these are things that are associated with biomass. So I always like to mention that vegetation contains about 90% of all of the elements on the periodic table. When you burn a vegetated watershed, and then you have rain and you export all of this ash and charcoal, you're essentially exporting the entire periodic table. So it's a fairly complex mixture of all kinds of elements. And we know that things like phosphate, calcium, some of these things that are associated with biomass end up becoming enriched in ash and then mobilized through the watershed. Same with metals. There's a lot of metals that are associated with biomass. And so all of these are enriched in the ash and then move through the watershed downstream.
As these materials move in the watersheds, we have secondary water quality effects. Like, for example, we get all these particulates that are moving into watershed that tend to deposit, creating the sediment deposition. And in doing so, like Jack mentioned, in addition to the metals, there's also a lot of nutrients, nitrogen and phosphorus that are stored in this biomass when it's burnt. So then are released to the water, and that increases primary production, potentially leading to the formation in some cases of algae blooms. And that sequence, whenever we have algae blooms, that can lead to low oxygen and eutrophication that can cause harmful effects to aquatic ecosystems. And in doing so, again, these are combustion processes, and we are inputting carbon into the watershed. And by introducing anaerobic or anoxic conditions, it can lead to more gradients in that redox microniches that we might have in this watershed. So we have here a picture of the watershed, how the materials flow, and just as a fun fact, this very beautiful background. It was of course we have just a diagram, but then we have a cool ChatGPT generated Bob Ross style painting, and we have a tree that is growing in the water. Just a fun fact. And as I was mentioning, all these nutrients that are released, they can form algae blooms and introduce this primary production. We have here two pictures from a paper where we have the unburned watershed upstream. You can see the rocks, the water is clear. And then a picture further downstream after the fire in this happened in this area, and you see this filamentous algae that are starting to grow, suggesting that these inputs from the fire, these ammonium ions and organic forms of nitrogen, can stimulate biological activity. Not just that, but there's also not just algae, but there's also possibilities of increased microbial activity. We're introducing again nutrients, especially ammonium, and that can lead over in the more medium long term into nitrification. So ammonium can be converted, can be oxidized into nitrite and then into nitrate. And nitrate, it can be quite toxic at certain levels, and ammonium as itself is also toxic, especially to fish. As an example here, when we have fires and then we have storms, there's also something to consider, that is this first flush effect. The first flush, as the name says, is the first series of storms following a fire, and they are very important for quantifying that nutrient, that carbon, that suspended solids flow into the watershed and eventually into stormwater. For the particular case that you're seeing in this slide, we were doing research on a 2022 coastal fire in Southern California that just happened to occur exactly in the middle of a creek called Aliso Creek near Laguna Beach. And what we see is that we have the fire that occurred around in May, and then we had the first small precipitation event occurring in the middle or towards the end of September of that year. And even though it was a small precipitation event, we did see a noticeable increase in carbon that is released. Again, just showing an example of the first flush effect that has been also observed in several other fires across the US and other places. This is work from one of my PhD students, Lisa Morgan here.
So all of these effects on the watershed also begin to influence our water resources in terms of treatment and our infrastructure and our ability to use this water effectively for our purposes. So, for example, our direct surface water intakes can be affected by all of the particulates, by all of that extra carbon. There's many things that are regulated components or constituents of water that need to be removed. And so by adding in these particulates and other solubilized components, that it makes it more difficult to treat that water. And other communities, especially in the WUI and some of these more rural areas where a lot of fires occur, depend on groundwater, on shallow groundwater, where water is obtained from springs. And so shallow groundwater is susceptible to changes in water quality due to burning, so ash and the leaching of some of those constituents of the ash into the subsurface can alter groundwater quality. But then also just the storage itself. Tanks are susceptible to burning, so damage can occur to the infrastructure, causing contamination in the system. Bank filtration is used in some communities, and this can have some problems related to wildfire in that all of those particulates, the algal growth that Chris mentioned, those can clog pores, and then the efficiency of bank filtration would potentially go down. Similarly, if you're under direct surface water influence and you have dissolved chemicals in the water, that could enter your pumping system and be taken up into the distribution system. So bank filtration is an area that could be affected by fire. And then, of course, residential wells. And this is something we saw a situation appear around Chico after the Camp Fire, where there's a lot of people that have homes in areas where their well is under direct surface water influence. They're living down alongside of a stream, for example, and they have a shallow well or shallow-ish well with pores in the cobble that are fairly large. So there's a lot of connectivity between the surface water and the groundwater in these areas. So you can perhaps have some transport of chemicals from the surface water into the groundwater. So the main thing that we're worried about in terms of conventional surface water treatment is particulates, or I should say is getting good disinfection, right? The purpose of drinking water treatment is to inactivate pathogens. So when we hit it with chlorine, it kills off anything that might make you sick. When you have a lot of particulate matter in your water, it makes that disinfection much less efficient. So but really, the purpose of surface water treatment is to remove particulates and anything that can interfere with the inactivation of pathogens. So obviously, particulates are a problem for this. So the key when trying to treat water that is maybe coming out of a burned watershed is to remove the particulates. And you could do this through settling if you have enough space and settling basins at your treatment plant, or just increase your coagulant dose, and you're essentially trying to rapidly settle out particulates from the water. Beyond the particulates, there's also a dissolved constituent. Next slide, Chris. So that dissolved organic carbon, or the carbon molecules that are coming out of the watershed, one of the issues here is that when you chlorinate water that has dissolved carbon in it, you form what are called disinfection byproducts. And this occurs pretty much anytime you treat surface water, fire or no fire. So these are regulated contaminants. There's maximum contaminant levels, and really anything coming out of a functioning drinking water treatment plant should be meeting the maximum contaminant levels for disinfection byproducts. Well, what happens in a watershed that is burned is that because there's more organic carbon in the water that's being treated, and because the fire thermally alters those molecules, it actually makes them more reactive. So you get a higher yield of these disinfection byproducts. So these are known carcinogens. Again, they're regulated. And really, if the treatment plant is functioning well, whatever is coming out of that plant should be below the MCLs. It really lies on it's the responsibility of the operators at the plant to ensure that they're meeting that level. It just causes a little bit more trouble for them responding to fire.
As an example, for example, here we have two different fires in Northern California, the Rocky Fire and Rag Fire. So samples collected in watersheds in the burnt areas had an increased amount of two subclasses of these disinfection byproducts that Jack was mentioning. On the left side, we have trihalomethanes. Those are single carbon molecules with three halogens, so either chlorine or sometimes bromine as well. On the right-hand side, we have haloacetic acids. Those are more water-soluble, and in both cases of these subfamilies, we have more of these disinfection byproducts formed after we have burnt organic matter in the watershed. And then the last panel on the right-hand side, we have a case where we had two smaller watersheds that one was burned, one was unburned. And what we saw was that there were more potential molecules that had chlorine in them after disinfection by chloramines, which is often a disinfectant used in California. So overall, more amounts of known disinfection byproducts possible because of the reactive changes of that organic matter, but also possibly more of unknown DBPs, disinfection byproducts that are formed after the fires modify the organic matter.
So another point here is that the treatment process is really at the front end of the distribution system. So it's collecting the water that's coming out of a potentially burned watershed. But the other side of this system is what's coming, not only going out of the treatment system, but then the whole distribution network. How do we get that water from the treatment facility to the end user? So when you turn on the water at your house, you have clean water coming out, right? So the point of this slide here is, I wanted to point out that the treatment system in many cases is actually a bottleneck for the amount of water that can enter into that distribution system. I'll also point out that bottleneck then influences the amount of water that's available to fill your storage tanks, to provide emergency flow for fighting fire, And then, of course, the water that's going to the homes. And in the case of a fire, where many people are using water at their home, their hoses, for example, sprinklers, you're putting a huge amount of demand on the distribution system. And it can only produce as much as that treatment system was designed for, generally. In some cases, some systems may be able to bypass the treatment system and put non-treated water into their network. But generally speaking, the treatment capacity is the bottleneck of the system. So what happens when you exceed, when your flow rates in the system exceed the capacity of the system is that you end up depressurizing your network. And what happens here is that you can actually create a vacuum, especially at the higher elevations in the system. And so when everybody turns on their sprinklers at their houses and you're trying to fight, multiple fires from the hydrant, you can actually pull in contaminants into the distribution network from burned structures, from melting water meters. That's what this picture is of down below. And so what happens is you get a number of these plastic associated or chemicals associated with plastic and melting plastic that are then inside of your distribution system. And this can happen at the water mains. It could be in the laterals going from the main to your house. It could be within the plumbing of your house. In some cases, I've heard of storage tanks themselves with plastic liners can heat up and melt and put plastic into the system. So this is where you get the VOCs and the which are volatile organic chemicals, and the semi-volatile organic chemicals contaminating the distribution system. And then finally, the other aspect of this is what happens down below the burned area. So the stormwater coming off of the burned urban environment is another complex issue where you have structures, you have vehicles, you have industrial areas, you have pharmacies, you have auto repair shops, and anything you can think of in a suburban or urban area. And then when you get a rain event, all of this exposed material potentially can enter the stormwater system and make its way into our watersheds, into our creeks, onto our beaches, down into our agricultural areas. So the downstream effects of this can also have ecological and human health implications. All right, so now we're going to shift gears, and both Chris and I are going to share some case studies from work that we've done individually. Chris, you want to go first?
Sure thing. Let me just switch presentations here a second. Stop share. All right. So I would like to share some of the work that we have been doing on drinking water in the 2025 Palisades and Eden fires, together the Los Angeles fires. And just an overview, as we know, the Los Angeles fire occurred in January of last year, actually close to just over a year ago. They both started on the same day, and they both ended at the end of January. There's a typo there with the Eden fire. On average, they had 14 and 23,000 acres that were burned. But what was very significant is, of course, that these fires occurred in very heavily urbanized areas as part of the LA County region. So we had a lot of structures that were destroyed, structures that were damaged, in addition to vegetation field. And we sought to identify what concerns in terms of drinking water for those homes that remained standing after the fires, to what extent these some of the pollution concerns in drinking water were detectable. This came out of some really pioneering work just a little bit more than 5 years ago from Kayleen Proctor and Andrew Walton, both professors at Purdue University, where volatile organic compounds, VOCs, were detected at very, very high levels following some of the fires in Northern California. And after that, as with collaboration with the California Public Health, Department of Public Health, they conducted this testing. So here on the right, we have a diagram, again, from Andrew Welton, that shows 3 main ways that we can get volatile organic compounds, or VOCs, in drinking water systems. So homes that get their water from centralized water treatment and distribution systems. And like Jack was mentioning, there's a whole series of parts to the distribution system. So some of the strains in the water distribution can lead to vacuums that can start soaking up some of that smoke. Plastic pipes themselves can release some chemicals into the water, which are VOCs, and you can have also back siphonage as well in some cases. Just as an example from these findings from the fires, Tubbs and campfires in Northern California, there were several volatile organic compounds that were detected. And in this work, in this study, benzene was significantly detected up to 40,000 times in, for example, you can see for city of Santa Rosa, 40,000 times the California maximum contaminant level, which is just 1 part per billion or microgram per liter. So this is based on drinking water regulation and guidance. So for example, for benzene, we have the state California MCL, that is, again, maximum contaminant level, that is 1 ppb. The federal is 5. Other volatile organic compounds that have been detected also include naphthalene, that has a drinking water equivalent guideline, so not an MCL, but this is the closest to a guideline value in drinking water of 700 parts per billion. Toluene and styrene. What they have in common, all these VOCs, is that they're aromatic compounds. They have rings in the structure, which make them both stable, although they're quite volatile, again, because of their name. And there's health concerns, especially with benzene, the maximum contaminant level being so low, and known carcinogenicity as well. So now leading to the work that we did, this is work that several of my students were involved in, led by my PhD student, Alison Tilsey, where we went out and sampled 53 homes between February 1st and April 14. So just after the firefighting activities had just concluded. And we had samples from both burnt areas. You see here in the map, the Palisades and the in-fire burnt zones highlighted in yellow. And the red dots are drinking water samples that we collected from kitchen sinks, again, in standing homes in these areas. There were some of the homes that were collected that were not part of the burn zones, but were still serviced by water utilities that were impacted. To do so, we collected samples that were sent to commercial labs using a direct-to-consumer sampling kit, and the VOCs were measured using a perch and trap gas chromatography coupled to mass spectrometry method. Is 524.2 that is routinely used for VOCs in drinking water. And it's a select panel of some contaminants, and not necessarily designed for fires, but it is one of the VOCs in water panel of compounds that we could have availability to test. What we found out in general were very optimistic news compared to other fires, meaning that there were very low VOC levels compared to that 40,000 times of the maximum contaminant level for benzene. However, we did see one home that was just above the California maximum contaminant level for benzene. That's again in the panel in the right-hand side, the orange slice of that bar. I think it was at 1.62 parts per billion. And again, the California maximum contaminant level is 1 parts per billion. We also, now we're analyzing the data, and several compounds have maximum contaminant levels. Those are the compounds that you see in the blue bars. However, a little bit less than half of other detected compounds do not have guidelines for maximum contaminant level. We have a data brief that we shared with participants and have also shared in town halls and other presentations in the QR code that you're welcome to scan as well, that summarize some of the overview of the findings. Now that we have had time to analyze all of the data together, what we were interested to understand is whether the current practices of treating water systems following fires, these type of fires are working to remove the contaminants. So what is the state of practice currently is to, number one, test, and number two, have the water utilities flush out water from those systems that have levels of VOCs that are above the maximum contaminant level. So we have the two regions. On the left-hand side, we have the Palisades. The right-hand side, we have in fire. There were several water utilities that were impacted by both fires. But on the left-hand side, we have those dark, just thick vertical black lines that were reported dates for flushing from the Los Angeles Drinking Water and Power Agency. And what we see is overall that if we put spatially the number of samples that we had, that we can see a spike, but then overall a decrease in the detections of VOCs. And of course, these are dots that were especially not at the same point repeatedly, but overall we can see a trend of decreasing VOCs. And that's just counting how many of these different compounds were detected, given that overall, again, the concentrations of the volatile organic compounds were quite low. So we use instead VOC detections or numbers of VOCs that were detected in a given sample. We also see a similar pattern for the in-fire area samples. We don't have the flushing dates for, in this case, homes that were serviced by the 4 water utilities that you see in the legend, but we see overall a similar pattern of a slow but continuous decrease in the number of detections as time went on when we collected the sample. Again, I think optimistic news that the lessons that were learned in those Northern California fires a little bit less than 10 years ago are now taken into testing and flushing to protect drinking water. So this has led us now to understand there's an overwhelming amount of information to get out of drinking water in fire impacted communities. And of course, again, there's guidelines, for example, here in the screenshot of the page that you see on the right-hand side. This is the California Water Board's guidance for homes impacted and areas impacted by fires, and it includes guidance on flushing pipes. So really important to once residents are ready to move back home to flush out any stagnant pipes. I think the recommendation is anywhere from at least 5 minutes. Also changing filters, especially fridge filters, ice making filters, and any other kind of filters that are installed at home, because they act as sponges. So if we have a buildup of volatile organic contaminants that can linger at home, so it's important to replace those, just as the regular operation and use of these filters needs changing. And then finally, the importance of testing. And then that can be led usually by the water utilities. So there's based on these 3 guidelines, flushing pipes, changing filters, and testing, what we're interested is to identify where are people getting, residents are getting their information on drinking water impacts after fires. So this is a project that one of my colleagues here, Dr. Monica Palta and Dr. Esther Lofton, as well as colleagues from the UCLA Luskin Center, were interested to get to know what kind of information would be most useful to have ready for current and future communities impacted by fire. So here's a QR code if you're interested in just getting to know more about the project. We're just starting this. We can keep you updated. So with that, I'd like to thank UC ANR and you all for your time to share a little bit of update about our work on drinking water, and all my students and funding to be able to do this work. So I'll stop here and I'll stop sharing and pass it on to Jack to discuss your case study.
Um, all right, so I'm going to go back and talk about the campfire a little bit. So the campfire occurred in 2018, and this was up in Northern California. We did a number of studies around the town of Paradise that was destroyed in this fire, and I want to summarize those. Let's advance this real quick. All right, so for those of you who may not be familiar, this is looking down on the perimeter of the campfire. This fire occurred in November of 2018, so about 7 years ago now. And the fire had an incredible rate of speed. It started early in the morning around 7 a.m. and more or less moved from the right-hand side of the perimeter all the way down to that highway on the left-hand side that you're looking at, really within one day, and burned across a number of communities, including the town of Paradise. And in total, there were almost 19,000 structures that were destroyed on that day. Actually, a few, I guess maybe up in Magalia a little bit later in the week, but most of those structures were destroyed on that day. So the town of Paradise on this image sits at that confluence where all of the colors of those different watersheds kind of meet in the middle of the fire perimeter, where you see the orange and the green and the purple and the teal all kind of coming together. That's really downtown Paradise. And so what we were interested in was looking at the effects of this urban burning on the downstream water quality and what was coming off the landscape and moving down into the Central Valley. I'll also just note, if you look at the bottom of that screen, that's Lake Oroville. Lake Oroville is drinking water for about 26 million people. And since the campfire, we've actually had another fire that burned the North Fork and the Middle Fork. So both the North Complex fire, which burned the Middle Fork a couple years after the campfire, and then the Dixie fire, which burned the North Fork. One of our largest, or the largest drinking water reservoir in the State Water Project has had almost the entire watershed burned in the last 10 years. So just thinking of the relevance of everything that we're talking about here, I mean, this is it. So in any case, so we were interested in looking at the downstream effects of this urban burning on water quality. When what you're looking at in the pinpoints here, all the locations that we sampled, pretty much for every storm throughout the water year. This is the hydrograph from that particular year. So this is Butte Creek, one of the major drainages coming out of that watershed, one of the larger drainages. Each red dot on the hydrograph represents a sampling trip where we went out, myself, colleagues at Chico State, went out and collected water samples from all of those points I just showed. So each dot represents about five to seven samples, depending on the day. So we sampled pretty consistently across the entire water year. We had a pretty wet year, so there was a lot of running around trying to collect samples. We also benefited in this project from having some pre-fire data, something that's really rare in the world of wildfire science. Somebody had been out a few years earlier studying some effects of mining in the water, some of these watersheds, and we were able to get that data. And that allowed us to compare pre and post-fire water quality. So the first thing I'll just point out here, looking at these two watersheds, the Clear Creek watershed in green and the Dry Creek watershed in purple, both of these originate in the town of Paradise. So they're draining right out of the town. There's no upstream, just it starts right in town. And what we see is that before and after fire, we have these major increases in the total concentrations of metals coming out of the watershed. Zinc was probably the most pronounced. In some cases, we're up around 3 orders of magnitude increases in the amount of zinc coming out of these urban watersheds. And zinc, by the way, it's associated with all kinds of things in our modern society. But one of the major things is car tires. And I've never got a clear count of the number of vehicles that burned with the campfire. We know there's 18,000 structures, and I think there was probably 2 to 3 vehicles per structure that burned. So that's a lot of tires, and that probably explains a lot of the zinc. Zinc makes up about 3% of a tire on a vehicle. So just FYI. When we looked within the watershed, what we see, and now just to orient you here, what I'm looking at here are all of the watersheds within our study. So this is all post-campfire. that year. And this is the filtered metal concentration. And filtered metals are of interest because they can be more bioavailable. They're not necessarily associated with particulates, right? So they can maybe be taken up more easily by organisms. And so what we're looking at here is post-wildfire metal content concentrations in the filtered sample. And these watersheds are organized from red, green, blue, and purple by the degree of urban destruction. So the destroyed structures per urban acre, essentially. You can think of that as kind of a density of the source of these metals on the landscape. And so we see this clear trend where, the more urban destruction we see, the higher concentrations of metals coming off in the watershed. Just comparing these, and just take a note real quick of the concentration. So for example, for lead over here on the far corner, we're going from about 0.1 to 1 micrograms per liter of lead. Zinc in the dissolved phase, somewhere in the realm of 1 to 10 microliters per liter. Comparing that to the total metal concentration, so this is the particulate associated metal. Now, you see these concentrations are much higher. We still have the same trend where the more destruction in the watershed that occurred, the higher the metal concentrations. And if you look at these concentrations now, going back to zinc, where we were from like 1 to 10, now we're 10 to over 100, and sometimes going up even higher than that. Similarly with lead, in some watersheds we get up a bit higher here, maybe not quite as pronounced. Some metals are more pronounced and tend to stay like in the particulate form, and some tend to stay more in the dissolved form. So what this is really telling us is that most of these metals, or many of these metals, actually remain in a particulate form, and a lot of the metal content coming out of the watershed is particulate associated, which is of interest in terms of managing stormwater and managing these metal, or managing how much metal is maybe getting into the watershed. I'll come back to that in a second. So just for a comparison, what does this mean? The individual sample that had the highest metal content that we measured throughout our study came from a mobile home park. This was an area that I thought would be pretty contaminated, mainly because you have a high density of structures all in one area. It's on a paved surface, so you have a lot of burned material, where when it rains, you have a lot of leaching and transport of material down toward the local waterway. And so when we sampled here, what we see at this particular location were, again, the highest concentrations, well, some of the higher concentrations, not maybe the highest, but we, zinc here was over 1,000 micrograms per liter, lead 6.5. So, but if you compare that to, let's say, over at the first column here, this is the aquatic habitat goals. We're really, for most of these, on the same order of magnitude as the aquatic habitat goals, right? A couple of them are a bit higher. Comparing it to urban stormwater runoff, also on the same order of magnitude, except again for zinc. So what does this tell us? It tells us that for as bad as the landscape looks, right, the actual concentrations of metals, at least in these samples, are not much different than what comes off of just a densely urbanized environment. So I think that's a little bit of good news. I think for how bad the landscape looked after these fires and the potential sources of contamination that we were observing, a lot of these concentrations were actually much lower than maybe we first thought they could be. We also looked at organics, and this was done in collaboration with Ed Kaloje at the University of Washington. And so Ed has a method for looking at a number of organic chemicals associated with stormwater. And so we ran that method, and then also did some non-targeted analysis as well. And so what we found is that initially after the fire, so in these samples here, if you're looking at Clear Creek, for example, which is on the far left, the green bar is the number one chemical that we found in pretty much all of our, well, we found it in almost all of our samples, but we found it at really high concentrations initially, was pentachlorophenol. Pentachlorophenol is a pesticide. It's used to treat wood. It seems to be the best kind of indicator of urban burning. It seemed to be everywhere after the fire, and it kind of tapers off as the season went on. So it kind of flushes out of the watershed. We also found a number of other compounds, not as high a concentrations, but other compounds associated with industrial activity and kind of typical, let's call it human fingerprint compounds. After the kind of toward the end of the winter and towards spring and of the following year, we started seeing a different chemical signature coming off the landscape. You see that over at Aquatic Center, which is downtown Paradise, where we started seeing more industrial associated compounds, vehicle associated compounds. And that had to do, I think, with the cleanup, just the amount of equipment on the landscape and their signature. And then the next year, the dominant signal was coming from herbicides, which were probably being used for managing vegetation on all the barren lots around Paradise. We also did some non-targeted analysis, which is basically just trying to see what's there, even though we don't have an internal standard or a specific method. And in this case, one of the things that popped up was the PFAS chemicals, the forever chemicals that we hear about a lot. It makes a lot of sense. These are recalcitrant compounds, or they're not really readily degradable. They're not really thermally degradable. In fact, they're used as firefighting foam, but none of that was used in the campfire for fighting the fire. So these also were pretty high, just based on the peak area in the instrument. It seemed like there was a lot of PFAS floating around. Those concentrations tapered off after the winter. So we had probably some pretty high concentrations of PFAS coming off the burn landscape initially. I'll say just a quick note, in a follow-up study, I also went around and looked at many of the stormwater sediments and some of the wattles put around town, and we also found a fair amount of accumulation of PFAS in those materials as well. That was, I guess, was my segue. I don't know why there's a line on that, but in any case, so this comes back to well, how do we prevent watershed contamination? And the answer is trying to contain the ash and those particulates, right? I mentioned that most of the metals are coming off the landscape as particles. So one of the ways to do that is to put these physical barriers on the landscape, both around burned structures, around burned vehicles, around drop inlets. There's different materials that we can use, both the straw wattle and what's called compost filter sock. And in our experience, these materials from the data showed that there was actually pretty good uptake of both metals, of PFAS, dioxins, and you can see in these images that in fact, that compost filter sock was doing a pretty good job of stopping all those sediments from getting into that drop inlet. So that's kind of the answers to what we can do to help promote, watershed protection after a fire. So I'll leave that there.
Thanks so much, Chris and Jack, for sharing some really helpful information about what are contaminants and some common safety concerns, as well as providing us with some real-world case studies and updating us on cutting-edge research in this field. We really appreciate it. Now we're going to transition to just a more open Q&A session, I think, with our speakers. We also have, as Chris mentioned, Dr. Monica Palta with UC Irvine and Cooperative Extension as well, who also works in water resources. It's more, again, an open-ended Q&A session. I think there's a small enough group where if folks feel comfortable, you can just raise your hand and unmute yourself and ask questions to our speakers. Yeah, Sophie.
Hi, great presentation. I was wondering, it was one of the last few slides. It said no PFAS AFFF. I was wondering what the AFFF is and like what that means.
The FFF is standing for firefighting foaming agent. I'm actually I think the A was originally for aerial firefighting foam, something along those lines. Aqueous, yeah, thanks. Aqueous firefighting foam, which wasn't used in the campfire. So that's used in like oftentimes in like aircraft fires or an industrial fire, you'll use that type of foam. Most fire retardants that are used in wildland fire actually ammonium phosphate, which is another story. Good
Thank
question.
you. If folks are thinking of some questions. Oh, Diana, do you have a question?
I do. I have a question to, I guess, all three. What is your water source? I mean, do you filter the water at home? Do you get it delivered? I'm just curious because I get my water source from the municipality, of the city, and I trust that it's supposed to be very good. But now, looking at all this, I'm wondering if because the uncertainty of what affects, our bodies, should we consider getting, water from delivered water or get one of those filters? What do you think?
You want me to jump in first? Guess we'll all talk. Okay. Yeah. So, it really depends on your unique situation. So, if you're on a municipal system and there's no advisories from your water provider, then it should be meeting all MCLs and you should be fine to drink that water, right? If your system isn't contaminated, et cetera. What we're talking about and what happened, let's say after the campfire or some of these other urban fires is that certain water utilities get damaged, and some people will have a house that maybe is not damaged, and they want to continue living there, but the water system itself is damaged. And so there becomes a question of, well, what should they do with their water system, trying to live in a house that has been fed by a damaged water system. I mean, that happened in the campfire for quite some time. There was a contamination issue that persisted, and people who had standing homes in the burned area were really struggling with how they should use that water and what they should do. So in the case of that, in the campfire, putting in a whole house filter was a popular solution for a lot of people. I think if you're on a system that hasn't been damaged and your utility or provider is saying that the water is safe, then I think you believe that and assume that it's safe. It should be safe. It has to be safe. Right? By law, it has to be safe. They have to be meeting their MCLs. Chris, do you have anything to add?
Yeah, I also I agree with everything that Jack says. And also I think something to note is that drinking water is regulated, right, by EPA. So that means that if you get water from a water utility, that water is tested, I think at least weekly. But other water sources, like for example, bottled water is not regulated by EPA. It's regulated by the Food and Drug Administration, so FDA. So maybe the what is tested is different. So I do think that in general, like learning more about water, like contaminants or just chemicals in water, right? The more informed you are, like the more nuanced, I think that would be helpful. And then also communicating with the water utility directly. Like sometimes if you get a water bill, maybe there's some context there. If you have questions about water utility, I think there are reports that the water utilities would post online their websites, and sometimes include in the water bill. Just they have to disclose if a particular chemical is above the maximum contaminant level, or if there's a recurrent issue. So I think that just knowing more, getting more informed, being here in this webinar, and continuing to your education, I think that's what I would suggest.
Yeah, and I agree with all of that. And I think the water utility is always a great primary source of information. And if you need some additional resources, the California Institute for Water Resources, which I believe is co-sponsoring this, and Camilo is on the call as well. I know that he contributed to development of this. But I'll just quickly share this website, and I think Katie's going to
I
send out.
posted it.
Oh,
in the
great.
chat, yeah.
But they have a bunch of fact sheets that help you understand drinking water sources, what public water systems are, whether your water is safe to drink, some information on contaminants. So this is a really good resource if you'd like to learn more about the safety of your tap water and how to interpret water quality information for tap water. So yeah, that's all I have to add.
Thank you. And yes, we will send a follow-up email to everybody who registered with a number of great resources from our collaborators and the fire network as well. Damaris?
Yes, hi. I was curious because this presentation is mostly about the surface water contamination, and I'm thinking about the whole like hydrological system in terms of like, would this affect the snowpack enough that it could be contaminated, and therefore it could just be like the contamination of surface water is like more long term than we think, and then also groundwater, like because most of the infrastructure is plastic, like how would that affect the aquifer in that sense as well?
Yeah, I think that, so if I can start. I think that you're hitting a lot of questions that, that we all have, right? This is like, how do you put it in the hydrogeological context? I think that regarding to like the question of the snowpack, I don't, as far as I'm aware, I haven't seen any work on that. So maybe that's work is needed on that, but I can imagine if you have aerosol, right? So atmospheric like transport of those smoke particulates that reach out the snow, and the signal is high enough. Like for example, Jack was mentioning how zinc, right, and pentachlorophenol were two markers that could be great to identify infrastructure related burning. I think that would be great. So we need more data, I think, and yeah, I think maybe Jack, you have more insights on those.
Yeah, I mean, it's a great question. And I think in terms of the snowpack, my first thought is it's always like a mass transfer issue, like how much mass of whatever chemical contaminant is being transported, and then, in what area and through what volume of snow or water is that being distributed, and then does that change the concentration to a point that it causes an issue. And I'll just say well, in the Southern California fires last year, there was a lot of deposition of ash. It blew the other way. It blew out into the ocean, and so there was actually measurable changes in seawater chemistry out into the Pacific Ocean. So when you think about going back to the mass transfer, well, if there's enough deposition coming out of these smoke plumes to change seawater chemistry miles out in the Pacific, then I think, yeah, there's probably enough to see at least a layer of deposition if it blew into the snowpack. But again, that would be probably kind of fire dependent and seasonal. There'd be some seasonality there and all of that. So yeah, I mean, it's a good question. I don't know that I've seen anybody address that specifically. In terms of groundwater, this is an area that is kind of a data gap right now in the science. There's a few papers out there that have started to look at groundwater, to look at well contamination. So far, I think that the biggest risk to like human health is when the actual well itself is damaged, when you have a well house, structure that burns, when you have the melting of the actual well casing, right? That can create a contaminant source. But in terms of kind of understanding how fire affects groundwater as a whole, I think this is still a very active area of investigation without a lot of results yet. So.
Thanks. All right, MJ, Lee.
Yeah, hi. Thanks for doing this presentation. I read a lot of stuff but in the paper and stuff, newspapers, but it's pretty high level, and you guys have presented so much great information here. I had a question about the slide that's called Fire Effects on Water Distribution Infrastructure. There's two little photos, and you said a little bit about it, but I couldn't figure out what those are photos of. Is that supposed to be home
Yeah,
piping or tubing? And
yeah, really good question. So one of those big blobs of plastic is actually a water meter. So that's the actual physical device that's measuring how much water you're using from your utility. Those water meters sit inside of like a concrete box, maybe with a metal
right.
lid outside of your house. And that came out of Paradise. And that little concrete box with the metal lid acted kind of like an oven, and it just heats up so much it melted the plastic water meter. So that's one of those blobs. And then you're
Oh,
looking at a piece of irrigation line, so that black ABS pipe that had pulled through the suction of the system had pulled a lot of melting plastic back into that irrigation line. And so you're seeing all of that gray plastic inside of it was all melting plastic getting sucked back into the system. It's kind of interesting. Yeah.
oh, wow. Thank you.
Good question.
Yeah. We have some questions in the Q&A section. I know Monica answered them, but for the sake of those watching the recording, I can read them out loud. So Christy asks, is there any testing of post-fire water once it moves further down channels from the watersheds in LA? Are tests taking place along, say, the Arroyo Seco or LA River all the way to the sea? What impact might these secondary and tertiary flows present that aren't immediately near the burn scars?
Yeah, I'm happy to. I mean, I see Monica shares some resources, especially I think SQUARP, that's the acronym at the end, right? SCCWRP is serving as a web platform for water quality monitoring. But we know in this region, right, in LA County area in Southern California, we have a lot of flow directly from those so a lot of slopes, right, leading into the coastal region through the Arroyo Seco, for instance, just like east, right of the, or sorry, a little bit west of the Eden Fire and the LA River as well. We know that everything goes through stormwater. There are some stormwater water quality infrastructure in some areas, but most of it does discharge into the ocean. So I think that there's a lot of potential of mobilization. Again, like what Jack was saying, like it's just a mass transfer, right? The pollutants are not volatilizing; they are transported from one area to another. So, in addition, we have maybe also atmospheric transport that those aerosols and thus eventually settle somewhere, right? So really depending on wind patterns as well. So again, I think that having resources like SQUARP, having the web platform where community organizations, researchers, government groups are inputting their data, I think that was going to help us identify the patterns of how these contaminants are mobilizing and their impacts.
Thanks. Sarah, also in the Q&A section asks, will anyone return to the Eaton and Palisades fire areas to test tap water again? She's particularly interested in carcinogenic disinfection byproducts. And Chris and Monica, do you want to elaborate on your responses?
Sure, I can elaborate a little bit more. So as part of the research that we did last year, we don't have currently like a follow-up of that same study. But with Monica and other colleagues, right, Esther Lofton as well, and UC ANR, like there's a project that trying to understand where people are getting water quality data information. So that would be a good way of getting just updated if you're in the were impacted by the Eden Palisades fire and have water quality concerns. And also like feel free to, that's open also invitation to the people in this webinar. If you have specific concerns in these areas for water quality, I'm happy to follow up by emails. Yeah, I don't know, Monica, you want to mention about the Eden Fire Residents United?
Yeah, and just to add to what Chris said, that QR code that he provided earlier, we really want to know exactly this kind of thing, like what contaminants are of concern to you, and also where you typically get your information or what information you need to better understand some of these contaminants and some of the risks. So please do join that mailing list if you're interested in kind of staying abreast of that. Yeah, so I know that the Eaton Fire Residents United organization is currently trying to pair residents with environmental testing opportunities and helping facilitate that. There are a lot of resources on their website as well that may be of interest or use even to those who were not in the fire affected areas. Let me just share that in the chat, the link to their organization. So there are resources here. Just more generally on testing, and I know that they have been facilitating trying to get tests done, although that's not from like a academic study perspective. It's more just to help residents out with testing to ensure that their home is safe to return to.
Thank you. Deb Sater, do you have a question?
Actually, I have a couple, but it sounds like I was concerned about groundwater contamination, but it sounds like not a lot of that is being done. Dr. Weber alluded to the smoke contamination, the particulates that didn't land necessarily. You guys tested watersheds that had fires in them. But what about contamination due to all of the debris and the smoke and whatever else went someplace else? Are other watersheds also being tested and compared as far as their proximity and, like with wind patterns and that sort of thing? How much would be deposited in a different watershed and affect the water there once it starts raining?
I'll start with that. So to me, this kind of comes back to the mass transport question, right? There's some amount. So when you have combustion, these large fires, you are emitting a lot of particulates into the atmosphere.
Sure.
So the particles settle out of the atmosphere kind of depending on size. So larger particles are going to settle closer to the fire, and then the farther away you get, you could have smoke particles, very, very fine particles that are traveling across the country, right? So you get, and you probably have seen this in these pictures of these smoke plumes that come out of various areas and they go everywhere. And so people are exposed to the smoke, hundreds of miles away from the actual source. But in terms of what's depositing in an amount that actually affects water quality in adjacent watersheds, I mean, I think you'd be fairly limited to, I'm kind of spitballing here in that, because I don't know exactly. I don't think there's no effect, but I also don't think there's a very large effect. I mean, there's probably some effect, but maybe limited, especially in forested watersheds where there's going to be some processing and retention of the particulates that settle into the, like a forested watershed. Some of those particles are going to be retained in the soil. They're not just going to flush out, into the water. So it's kind of a complicated question. On the other hand, if you are in an urban area and you have a lot of smoke deposition on impervious surfaces like concrete and asphalt, of course you can have ash deposition miles and miles away from a fire, and maybe you've experienced this. I know I have here in Chico, and all of our Northern California fires, we get these periods of smoke and ash deposition where you go out to your car in the morning and there's a layer of smoke on the windshield, or of dust on the windshield, ash. Yeah, so certainly all of that's washing off into the watershed. You get that first rain and all of that dust that's, deposited on those surfaces are washing off. So yeah, it does. I'm sure it creates a measurable effect. That's a roundabout answer for you. I don't know if I gave you enough detail there, but conceptually, that's how I would think about it. Yeah. But you're still muted.
Oh, I think you're muted.
There we go. I didn't want to follow up, but it sounds like, I mean, you guys are really interested in the water infrastructure and utilities and all that kind of a stuff. Is anyone also looking at environmental impact on the plants in that area? I mean, how much of those really nasty chemicals did plants tend to take up? I don't really know, but that's kind of another question that comes to mind as far as the fallout from these massive fires we've had over the last 10 or 12 years in particular.
Yeah, I can speak to that a little bit because my focus is a little bit more on the environmental side than the tap water side. There was a very, very broad suite of research being done in the environmental sphere. I know after the LA fires for sure. Chris and I actually just attended a conference at UCLA a few weeks ago, where some of these studies are starting to come out. But a lot of testing of the soils, a lot of testing of the air, a lot of testing of the extent of impacted systems. So addressing some of those downwind concerns that you were talking about. So there's a lot of science emerging from the LA fires about that. I think also a lot of interest and concern over exactly what you're talking about, which is that soil contamination is persisting even when the contaminated water has gone away and flushed away. And some of these contaminants do translocate into plants, like depending on the metals. So again, I'll if you're interested in learning a little bit more about this in a more digestible way that isn't like reading a bunch of scientific papers, definitely the link that I provided on the Eaton Fire resources would talk a little bit about that because the problem is that a lot of the properties after the LA fires are still too contaminated for residents to go back, and they don't know if they can handle the soils. They don't know if it's okay to handle the vegetation. They don't know if some of the contamination has gotten into the vegetation. So these are all things that are actively being tested for and are of concern for residents for sure. So that resource page may give a little bit more insight into that.
Thanks.
Okay, thanks.
Also, just wanted to point out our next After the Fire webinar series, which will be next Tuesday night from 5:30 to 6:30, covers soil contamination and remediation, and will feature all of those things that Monica talked about in the context of the LA fires of 2025 and the 2020 CSU complex fire in Santa Cruz County. We have a question. I'll give this to Chris first from Sophie in the chat. Just what is a disinfectant?
Sure. So drinking water is treated with traditionally with chlorine, like just to disinfect. That means to kill essentially disease-causing microorganisms, so bacteria, protozoa. So that once you get water at home, you don't get these microorganisms that could cause harm. And in drinking water systems, this disinfectant now chlorine is not used as much. There's other soft, like a little bit less reactive chemicals that are added. I think in the LA area, like chloramines, all systems I think use chloramines to do the same job. Unfortunately, it's not selective to just react with bacteria, so it will react with any organic matter, any organic molecule. And in doing so, unfortunately, it does produce what are called disinfection byproducts. Now, disinfection byproducts are quite volatile as well. So there's they could remain in the water system mainly because like it's the disinfectant, the chlorine or the chloramines are dosed a little bit higher than the minimum, and that's so that there's still a little bit left of that disinfection power to prevent any microbial regrowth from the time that the water leaves the water treatment plant to the time that you open the faucet at home. So that's I hope that clarifies a little bit. So we think essentially chlorine or chloramines are the most common ones.
Thank you. We have a question from Christy B in the Q&A session. And Christy, I'm not sure if you feel comfortable unmuting yourself and asking directly, but I wasn't sure if this is a follow-up question to Monica or Chris about their specific work, or if you had a specific question that you wanted to ask our speakers.
Yeah, I was just, my earlier question was leading me to think of something more specific. And if it's too much for this and you want to follow up with me later, I'm curious about up in the Eaton Fire in Altadena and above the WUI, where we have some of these smaller water companies. And I know I was aware that some of them were, or at least one of them was destroyed, and the water was flowing freely through whatever would have been the contaminants from that system that was in place. And it would be coming down Millard Canyon into the watershed, the Hahamonga watershed, and of course down all the way out through the systems. But do you know if that was able to be shut off, or if they were able to stop that water? Because it was April that was still flowing freely from up there, and that was, to me, that seemed pretty late after the fire for the water to be moving still with the contaminants. And in addition, there's like the old mines up there and other kind of human historical remnants left behind.
I don't know the specific details of the water utilities, but I'll just point out something that both Chris and I mentioned while we were speaking. This class of compounds that are affecting the distribution systems are these volatile organic compounds. And one of the things about a volatile organic compound is that it is just that, it's volatile. In other words, it wants to leave the water and go into the air. And in the pressurized distribution system, that doesn't happen because it's a closed system. You turn on your tap and now that chemical is still there. But if you were to open that up to water, or to the water to air, you would get some of those compounds being released to the atmosphere. So depending on the type of contamination, I'm not sure exactly what you're referring to. I mean, I'm assuming you're referring to VOC contamination in the distribution system, and I don't have a picture in my head of how they kept it open to run into the creek. But maybe if you can clarify that, I could answer a little bit more. But I don't know, Chris, do you have any other thoughts on that? Or
Yeah, I can just add that I believe the system, and I'm not too familiar with the system itself, but this small water company, and I believe it was Lincoln, that that their whole system was destroyed in the fire, and so it caused the water to just run freely down because it didn't have any system in place up there where they were, I guess, collecting the water.
Yeah, I think that, yeah, knowing a little bit more specifics, I think from the water utilities that can provide us a little bit more information. But I think that something, I don't know if relative to the water utilities, the Eden Fire did have a lot more water utilities than the Palisades Fire that were impacted, and some of them are on the smaller side, right? So I think they have faced larger, especially financial challenges, right, to bring water online. I think there's 4 or 5. For example, the samples that we got were only from 4 of the agents of the water utilities in that area, but there were at least 2 other ones that we were not able to collect samples because maybe there were more density of the burnt homes in that area, or were able to get participants from those other water utilities. But it seems to be a challenge. But the main drinking water contaminants that we're talking about would dissipate, like Jack is saying. Of course, there might be other things as well, and the mines. Well, that's a whole other topic. I think in mining, drainage, any kind of metal release, right? Mm-hmm.
Yeah, and I'll just add, I think I put this in the Q&A, but Heal the Bay has been doing water quality monitoring in the coastal areas that are fed by these water bodies that went through the fire affected areas. And I know that they are currently trying to come up with ongoing water monitoring protocols. The problem was that there wasn't really like a monitoring plan in place ahead of time. So it was sort of difficult to capture like exactly what you're talking about, these sort of individual waterways, and there wasn't a lot of guidance on where to test or what to test for. So that is now really coming around in a very powerful way with SCWRP sort of centralizing all of the data, like Chris said before. So I would definitely recommend going to that platform if you're interested. But at minimum, I put a link in the chat that has the various reports that were done by Heal the Bay. So that might provide some insight also into like how long the contamination was persisting and what kind of sampling was being done to monitor.
Thank you.
Mm-hmm.
All right, does anyone else have any last minute questions? I think we have time for one more. Well,
I have a question.
Oh, yeah, go ahead.
Okay, thanks. Has the vegetation and wildlife come back from the 2018 campfire? The growth?
Yeah, I mean, to some extent, I mean, the landscape looks a little different for sure. There was a lot of trees that were removed from the landscape that were either hazard trees, needed to be fell, or so it looks a little different for sure. But there's definitely things growing. It's actually amazing how quickly things come back. And especially here in the Central Valley of California, we have a lot of water and sunshine, and things grow. So. I think in some areas it's coming back as more of a chaparral style
Right.
there'll be a period of succession where there's chaparral. And then there's still plenty of areas with green trees as well. So it definitely looks a bit more lively than it did right after the fire. It was pretty dismal right after the fire, but it is amazing how the landscape does rebound and is resilient.
And one more question. Monica mentioned that she's more into the environment. Has there been any changes with habitat, like the animals, the birds? Have they looked at their DNA or RNA at all? Has there been any testing there?
That is a great question, and I don't know the answer. I could certainly look into whether work has been done on that. But I know that there is ongoing marine monitoring, throughout the Southern California coast. I don't know if they're like looking specifically at how the fire has impacted those wildlife, but I'm sure that work is being done. Certainly, there's like a report card that needs to be made every year based on monitoring wildlife in coastal areas. So there might be something along those lines, but I don't know about anything specific. It's a great question. Mm-hmm.
Cool. Well, that's all the time that we have tonight. Before we conclude, I just want to thank both Chris, Jack, and Monica for joining us this evening, collaborating with us on this webinar, and presenting some great work. Thanks also to our partners at the California Institute of Water Resources for co-sponsoring this webinar with us again, and I hope everyone has a wonderful evening.